Distribute the 4 to every term.
Take a walk through a forest, and you'll notice quantities and physical relationships are already there. Long before we ever write an equation on paper, math exists in the physical world. Watch this scene first. Look at the labels carved into the mossy stone and wooden marker. Here, along the foxglove equation path, you can see quantities mapped out across the roots. The mathematical notation simply records what is already physically there. Seeing the items grouped in the environment allows us to track the total quantity before a single symbol is written. Examine this logic diagram carved into the root structure. We start with the expression 4 times the group x plus 3. Our goal is to rewrite this expression by revealing its underlying structure without changing its total value. 4 distinct groups are laid out, each containing an x symbol and 3 pebbles. We apply the distributive property by multiplying the outside coefficient 4 by the first inside variable x. Grouping those 4 x's together gives us 4x. Next, we account for the pebbles. The outside 4 must also be multiplied by the 3 pebbles inside each group. When we combine those, 4 groups of 3 gives us 12. Distributing that multiplier across all the internal terms alters the form of our expression, but the total quantity remains the same. 4 times the group x plus 3 is equal to 4x plus 12. Moving along the branch path, we find a new acorn tag displaying the expression 2y plus y. Here, we want to combine like variables to simplify the notation. You can see the 2y represented as 2 distinct groupings. Notice the standalone y next to it.
The bundle opens into 4x plus 12.
A single variable written by itself represents exactly one group of that variable. When we add that single group of y to the existing 2 groups, they merge into 3 identical groupings. By combining identical terms, we create a simpler, equivalent expression that is easier to work with. 2y plus 1y gives us a total of 3y. Look at this large bark surface displaying 3 times the group a plus 2 plus 1. When we have a mixed expression, we determine which property must be applied first to clear the grouping before any addition can occur. We start by applying the distributive property strictly to the grouped terms. The 3 distributes to the a and the 2, giving us 3a plus 6. The plus 1 remains isolated and untouched during this step. With the grouping cleared, we can combine our remaining constant terms. Focusing on these riverstones, we simply add the 6 and the 1 to get 7. Adhering strictly to the order of operations when combining these tools ensures the final expression, 3a plus 7, remains equivalent to the original. Whether we are distributing multipliers across a group or combining like terms, the underlying purpose is the same. We are generating equivalent expressions. Looking back down the woodland path, we have a permanent, consolidated record of the mathematical relationships we discovered. 4 times the group x plus 3 equals 4x plus 12. 2y plus y equals 3y. And 3 times the group a plus 2 plus 1 simplifies to 3a plus 7. The notation records the relationships established by the environment. Which specific marks in the environment prove the mathematical relationship? And how does the physical movement make those rules true?
Like terms gather without changing the value.